Tornadoes are among the world's most extreme and deadly phenomena. They are wind vortices with the powerful ability to destroy everything in their path. Their ability to be unpredictable contributes to their deadly power. Tornadoes currently form in only a few locations in the planet, but this may be changing. Some scientists believe that as a result of climate change, tornadoes may begin to spawn in previously uncharted territory. They may also get larger and more destructive as the atmosphere's temperature changes, eventually creating supertornadoes. How destructive would these supertornadoes be, and how might we prevent them? Stay with us to the end to find out. Tornadoes have caused havoc and ruin throughout history, leaving a trail of devastation that survivors will never forget. A tornado is a weather phenomena defined by a whirling air column that extends from a storm cloud to the Earth's surface. Although the size, duration, and strength of these revolving air columns vary, one thing is constant: they are exceedingly deadly. To understand how we can deal with super tornadoes in the future, we must first understand normal tornadoes and how they occur. Tornadoes require very particular meteorological conditions that are divided into stages. The first required requirement is the presence of an unstable atmosphere. This requires a large variation in temperature and humidity between different layers of the atmosphere, resulting in a vertical gradient of temperature and pressure. Several reasons can contribute to this instability, including solar radiation, wind convergence near the surface, and a warm air mass colliding with a moist air mass. The temperature differential between the strata generates an oscillation which leads to quick, intense winds, and finally, a tornado. Of course, this situation does not arise spontaneously, and it can only occur as a result of more significant phenomena such as cold fronts or places of wind convergence, such as mountains and plains near the Earth's polar regions. These systems can generate the energy required to fuel the storm and produce favorable circumstances for tornado formation. It should be noted that the majority of tornadoes are caused by supercell-type storms, which are long-lasting, large-scale storms with sustained spin. These storms can produce high upward winds, which can initiate and sustain the rotation required to form a tornado. Wind clashes are the final component that contribute to the formation of a tornado. Remember that warm air rises and cold air descends, so when two air masses of differing temperatures clash, one attempts to ascend and the other seeks to fall. This causes air masses to rotate, and if this happens within a supercell-type storm, the wind rotation can reverse direction and travel from horizontal to vertical, resulting in a mesocyclone, which is essentially the forerunner to a tornado. If the mesocyclone is nourished by different air masses from a storm, it will progressively evolve into a funnel that descends until it reaches the surface, at which point a tornado will occur. A normal tornado is made up of several unique sections. The funnel is the most distinguishing feature of a tornado, consisting of the outward visible portion that reaches from the ground to the clouds. The base of a tornado is the most deadly since it is where the funnel meets the Earth's surface and causes the most destruction. The winds are strongest there, and the atmospheric pressure is lowest. The tremendously strong winds that swirl around the funnel are contained within the base. These gusts can reach extraordinary speeds and account for the majority of a tornado's destruction. Finally, we have the mother cloud, or storm cloud, from which the tornado is formed. It is typically composed of a big, dense cumulonimbus cloud that occurs in conjunction with strong thunderstorms. Tornadoes are classed into numerous kinds based on their formation and intensity. The most common tornadoes are supercell tornadoes, which form from the above-mentioned supercell thunderstorms. These tornadoes are the largest, long-lasting, most destructive, and significant, reaching distances of many kilometers before disintegrating. Another form of tornado is the wedge tornado, which has a wide cone shape at its base. Wedge tornadoes, while their rarity, are typically highly damaging due to their size and strength. Finally, multiple tornadoes are an intriguing phenomena in which two or more tornadoes originate and rotate around the same storm system. These occurrences can be considerably more deadly because the area of destruction is larger and hence has the potential to wipe out more areas. On April 2, 1957, multiple tornadoes struck Dallas, Texas. As we can see, The formation of a tornado necessitates exceptional conditions and the presence of numerous components that are only found in a few spots on the planet. The only places on the planet where tornadoes can form are South Africa, much of Europe, except for the majority of the Alps, Western and Eastern Australia, New Zealand, Bangladesh, Eastern India, Japan, the Philippines, Canada, and a large area in South America where the countries of Argentina converge, Bolivia, Brazil, Paraguay, and Uruguay. However, the United States and South America have the largest tornado presence as they are the only two places with tornado pathways. The most famous is Tornado Alley, a wide region in the central United States where tornadoes thrive, encompassing parts of Texas, Oklahoma, Kansas, and Nebraska. The second tornado corridor is located in South America, namely in the humid Pampas. Because of the Pampean Plains' vast extent, this location has all of the prerequisites for tornadoes and violent storms to emerge. The cold air from Patagonia and Antarctica collides with the hot, humid, and fast air from Brazil, northern Argentina, and Paraguay, as well as the dry air from the Andes Mountains. This combination produces intense storms that frequently reach supercell status, and many produce intense hail and tornadoes. While tornadoes in South America are known to be less intense and less frequent than those in the United States, this may change in the future due to climate change and, in particular, the destruction of the Amazon rainforest. Winds are getting quicker. As the Earth warms, scientists are observing stronger winds in various locations. Wind speed is one of tornadoes' most defining qualities. The winds associated with these whirlwinds can reach tremendous speeds, often exceeding 200 miles per hour or 300 kilometers per hour in extreme circumstances. This tremendous power can pull a house apart and uproot trees. However, if the winds increase in speed, tornadoes might become more destructive. Variances in atmospheric temperature between areas cause variances in air density and thus atmospheric pressure. Meteorologists refer to these pressure variations as a pressure gradient, which drives the flow of air or wind. The larger the temperature difference between the two places, the greater the pressure gradient and consequently, the wind speed. This means that as temperature disparities widen, tornadoes grow in size and speed. This will be seen mostly in places where these pressure gradients are most visible, often known as tornado pathways. However, when global temperatures rise, the circumstances required for a tornado to form may become present in areas where tornadoes have never occurred before. This means that certain countries throughout the world may begin to see tornadoes, and those that do, such as the United States, may see increasingly destructive storms. The Fujita scale is a measurement system that reflects the severity of tornado damage based on wind speed. This scale goes from F0 to F5, with F5 being the most destructive tornadoes. These can generate winds of up to 318 miles per hour, lifting a full house into the air and even uprooting an entire building from its foundation. These are the most devastating tornadoes possible. Assume that global temperatures continue to fluctuate rapidly. In that situation, we will see even more catastrophic tornadoes with high winds, which will eventually fall off the Fujita scale and be designated as supertornadoes. At Insane Curiosity, we believe it would be a fantastic name for this type of tornado, but we'd need your feedback. What name would you give to a tornado that exceeds the F5 rating? These supertornadoes would be completely out of the ordinary with wind speeds of up to 400 miles per hour, far above those of an F5 class tornado. With that energy, these mega tornadoes may completely clear the area they pass through, uprooting everything in their path, houses, trees, and buildings, lifting them into the skies and dropping them hundreds of kilometers distant. The wind would be so strong that it would create a whirlwind of boulders and debris around it, crashing against whatever structures that remained standing. Supertornadoes are unquestionably one of the most destructive and deadly natural disasters, but will they ever exist? One of the most important debates in tornado research is how climate change may alter the frequency and intensity of these events. While science is still working to completely grasp this link, there are some theories and observations to examine. Rising global temperatures due to climate change may generate more favorable atmospheric conditions for the creation of severe storms, resulting in more violent tornadoes. However, other experts argue that the picture is more convoluted and that more research is needed to understand how climate change affects tornadoes. Changes in atmospheric patterns may cause tornado frequency and strength to increase in some locations, while decreasing in others. Finally, it is apparent that tornadoes will remain a serious and ongoing threat as we confront the difficulties of climate change. We must continue to investigate and monitor these incidents in order to better understand their behavior and take real measures to safeguard ourselves. Now we want to know your thoughts. Will climate change generate super tornadoes in the future? Tell us what you think in the comments.